In section 1.4, we're going to be talking about what are called quadratic equations. Now, if you remember back to the chart that we had when we were talking about different types of polynomials, quadratic means that the highest power of x is 2. So just a little bit of vocabulary to get started. We have what's called standard form. And that looks like this. ax squared plus bx plus c. And it's going to be equal to 0. That's going to allow us to find the x-intercepts. Now sometimes it's equal to y. But if you want to find the x-intercepts, remember what we talked about before, we make y equal to 0, and that's what standard form looks like. Now there's a few different ways to solve an equation if it's in standard form. And we'll be going over all of these. One way to solve is by factoring, using the AC method. Another way to solve is with roots. Third way to solve is by completing the square. Now when we complete the square, when we get there, you'll see it's forcing something to factor that doesn't factor an easy way. So we'll talk about that in a little bit. And then the last technique is called using the quadratic formula. So let's go through these one by one. The first technique is called factoring. So we're going to solve the following by factoring. Sometimes this is called the zero factor property. Meaning once you factor, you set your factors equal to 0, and that'll tell you answers for x. So let's take a look at something like this. Let's say x squared plus 2x minus 8 is equal to 0. Now when we talk about factoring, remember we said that there were 4 ways that we know so far. One is by looking for a GCF. Another technique is by grouping. If there's an even number of terms, like 4 terms, we cut it down the middle. The third technique is if we have a trinomial, which is what we have here. And then the last technique is called special cases. And with special cases, we look to add a difference of squares and a sum or difference of cubes. And there was supplemental material available for this. But factoring is the most important thing in math, and we always factor by starting with the GCF, then we go to grouping, and that's how we do it. So taking a look at this example, there is no GCF. We can't group it because there's 3 terms, so we use trinomial factoring. The way that I teach trinomial factoring is we look for 2 numbers that multiply to be a times c. So 1 times negative 8 is negative 8. And what 2 numbers add up to be b, or 2. So 2 numbers that multiply to equal negative 8, and the same 2 numbers they have to add to be our middle term, 2. So usually I'll factor negative 8, like 1 and 8, they're not going to add to be 2. 2 and 4, well, if they have to add to be 2, if that's negative, then that'll get the job done. So my numbers are negative 2 and 4. So instead of having 2x, what I'm actually going to do is I'm going to break this up to be 2 terms and then factor by grouping. So I get 1x squared minus 2x plus 4x minus 8 is equal to 0. By grouping, we could cut it down the middle and take out a GCF. We could take out a 4 here. And we get x minus 2 That's our GCF between this term and this term, and we're left with x plus 4. Now at this point, we want to know, when you have two numbers that multiply together to be 0, that means one of those is 0. So if x minus 2 is 0, that would happen if x was equal to 2. That's one of our answers. And if x plus 4 was equal to 0, that would happen when x is equal to negative 4. If you plug either of these back into the original problem, you would get 0. So those are our x-intercepts and solutions to this problem. Let's try one more. What if we had 2x squared minus x minus 15 is equal to 0? Do it the same way. The AC would be negative 30. Middle number is negative 1. So what numbers multiply to be 30 and add up to be negative 1? Well, negative 6 and 5 would do that. So again, we're going to replace this negative 1x with our two numbers. We'll have 2x squared minus 6x plus 5x plus 5 is equal to 0. Cut it down the middle. We could take out a 2x, get x minus 3. Take out a 5. We're left with, let's see here, I forgot the 1 here. It was supposed to be minus 15. So if we take out a 5, we do get x minus 3. So you know you did it correctly if these are the same. Finishing up this problem, we'll write what's in common. We'll write what's left over. And now let's solve using the 0 factor property. We're going to set each factor equal to 0. And we'll get x is 3. And our other answer would be x is equal to negative 5/2. That's how we solve a quadratic equation by factoring. Next is by using square roots. Let's take a look at a problem like this. What if we had x squared minus 1 is equal to 0? Well, the easiest way to do this would just be to bring the 1 on the other side. So we have all the x's on one side here and take the square root. But remember what we said, if we take an even root of an even power and get an odd power answer, we need absolute value. So we would actually get x would equal 1 and x would equal negative 1. That's the easiest way to do this. Let's take a look at another problem by using square roots. What if we had 48 minus x squared is equal to 0? Well, let's get the x by itself. That's what solve means. By bringing the 48 over, dividing by negative 1, get x squared is equal to 48. We'll take the square root just like we did before. We'll get absolute value. Anytime you take the square root of something squared, you get absolute value. And the square root of 48 we're going to have to reduce. And instead of breaking this up like we did before, having x equals square root of 48, x equals negative square root of 48, it might just be easier for us to just write positive or negative square root of 48. We could have done that right here. Instead of breaking it up, we could have just brought this absolute value over and just said x was equal to plus or minus 1. It's the same thing, it's just a little bit easier to write. So now let's take care of the square root of 48. Well, I know that 4 goes into 48 12 times. Square root of 4, square root of 12 could even be broken down. So let's just keep factoring using our prime factorization. And I'm looking for groups of 2 because this is a square root. And just have a 3 left over. So our answer for this problem would be x is equal to plus or minus. There's actually 2 groups of 2, so I'm going to write this group right next to it, and then the 3 left over. Or x would equal plus or minus 4 root 3. One last problem with this. Let's try negative 2x plus 5 squared is equal to negative 8. Well, let's go ahead and take the square root of both sides. If we want to get that x by itself, it's trapped inside of that square, right? So we could use the inverse operation, or take the square root of both sides. Anytime you take the square root of something squared, that turns into absolute value. And we have a square root of a negative. We've already talked about how to handle this. We could take care of the square root of negative 1, which we know is I, and we'll do the square root of 8. Square root of 8 is really just 2 times 4. 4 is 2 times 2, so we have one group of 2's with a 2 left over. So we get the absolute value of negative 2x plus 5 is equal to 2i, and then the square root of 2. Now, because this looks a little bit more complicated than the last problem, we just had one number equal to here, that's why we put the plus or minus. You could always break it up, and that's what I'm going to do here. So I'm going to say the absolute value of negative, the absolute value goes away. So I'm going to write negative 2x plus 5 is equal to 2i root 2, and negative 2x plus 5 is equal to negative 2i root 2. We'll just finish this up by subtracting 5 on both sides, and then dividing by negative 2. So x would equal, it doesn't matter, usually we put radicals at the end, but it doesn't matter how you want to write this here. And another answer, we could do the same thing over here. And then divide by negative 2. We get x is equal to, again, negative 5, but in this case it's minus 2i root 2 over negative 2. Those would be our two answers for this. There's something called the fundamental theorem of algebra. And what that says is anytime you have the highest power of x, like let's say you have x to the second, like these quadratic equations, you're going to have two answers. So I'm just going to write this here as a side note. We'll talk more about that later in the course. But the fundamental theorem of algebra says that you will have as many x-intercepts as the highest power of x. So for these problems, these are all quadratic. It's x squared. Well, we have two answers for all of these problems. We have two more techniques to talk about. We'll talk about this third technique. We're going to be looking at how to solve by completing the square. This is a pretty cool technique. Really what we're doing is we're forcing something that doesn't factor to factor. So let's take a look at an easy example first, just so you could get the technique down. Let's say we had x squared plus 4x minus 5 is equal to 0. And I just want to show you how to complete the square on this. Even though we could factor, let me just show you the steps for this. There's 4 steps. And it might be a little bit different than if you learned this before, but using this technique will actually know how to do something coming up later in the course with getting a quadratic into vertex form. So we're actually killing two birds with one stone if you do it my way. So the first step is we isolate the x's. What that looks like is we just get the x's by themselves and get that negative 5 out of the way. We're not changing the value, we're just kind of pushing it out of the way. Second step is we factor out the leading coefficient from the x's. So leading coefficient means the number in front of the highest power of x. In this case, it's 1. We're going to actually be factoring that number out of the x's. So that's easy. We'll just divide everything here by 1. For our third step, we take half of the middle number, and then we're going to square it. So what that means is the middle number here is 4x. So 4 divided by 2, we're going to square it and put that number right here. That's forcing it to be what's called a perfect square. So in this case, we're going to get x squared plus 4x. Half of 4 is 2. 2 squared is 4. And then for our fourth step, we're going to multiply the new number by the front and subtract. Because think about what we're doing here. When you have an equation, we just added 4, right? We added really 1 times 4. That makes the equation misbalanced or unbalanced. Think of it like a seesaw. If you add 4, in order to get it back balanced, we have to subtract 4. So we do 4 times 1 is 4, and subtract it. Now we're ready to finish this by factoring. This is always going to factor to be half of the middle. X squared plus 4x plus 4 is x plus 2 times x plus 2. So always going to be this middle number divided by 2. But we could just write it x plus 2 squared. Negative 4 minus 5 is negative 9. And now in this case, we could just solve it by using radicals. We could bring the 9 on the other side. Take the square root of both sides. Remember your absolute value. We could write plus or minus if you want, or we could write it separately. Generally, what we do is we just put the plus or minus. It's a little less writing. And of course, we subtract the 2. And we're going to put that in front of the plus or minus sign. So we get x is equal to negative 2 plus or minus 3. If you do negative 2 plus 3, you get 1. And if you do negative 2 minus 3, you get negative 5. So these are our two answers here. Interesting enough, this problem was a factorable problem. And watch, if we were to factor it, it's x squared plus 4x minus 5 equals 0. It would factor to be x plus 5 times x minus 1. And you'd get exactly the same answer. It's just another technique. Now, if it didn't factor, you would have to use completing the square. We'll look at one more example, maybe make this one a little harder. What if the problem was negative 3x squared plus 9x is equal to 7? We'll follow our 4 steps. First thing, let's get everything on the left side. Whenever we're solving an advanced equation, it's always best to have it equal to 0. The next step was we get the x's by themselves. And we could factor out the leading coefficient. Now factor just means divide by it. Okay, so this was our first step. This was our second step, taking out the leading coefficient. Now we're ready for the next step. Now we're going to have to work with fractions. So the rule is you take half of the middle and then square it. So negative 3 over 2 squared would be 9/4. That number is going to go right here. So let me write this all out in our steps. The third step, we would get negative 3 times x squared minus 3x plus 9/4 minus 7 is equal to 0. For our last step, what we do is we take our new number, multiply it by the front, and then subtract it. Generally, people don't like this because you're forced to work with fractions. 9/4 times -3 is -27/4. So we're going to be subtracting -27/4. So let's clean this up at this point. Remember what I told you. This always factors to be x and then half of the middle. And then we have -7 minus -27/4. And that comes out to -1/4. Now we're ready to solve this using radicals. We could bring the 1/4 on the other side. Divide by -3. We're looking to get the x by itself. And we could go ahead and take the square root. Remember, when you're dividing by -3, that's the same thing as multiplying by 1 over -3. So that's where that number came from. Let's take the square root. And we get the absolute value of x minus 3/2 is equal to, well, the square root of -1 is just I, right? Remember, we're taking the square root of the top and bottom of this fraction. And then we also have to take the square root of 12. Now, the square root of 12 is just the square root of 4 times the square root of 3, or 2√3. Well, that's not okay because we have a radical in the denominator. There's just one term with a radical, so we conjugate it. And we wind up getting x minus 3/2 is equal to plus or minus I√3 over 2 times the square root of 9, or 2 times 3. So as far as our final answer for this, we just have to bring this -3/2 over by adding it on both sides. We get x is equal to 3/2 plus or minus I√3 over 6. And that would be an acceptable answer. If you wanted to get a common denominator, you could make it into 6. So let me just show you what that would look like. We have to multiply this by 3 over 3. That would be 9 over 6, plus or minus, multiply this by 2 over 2, 2I√3 over 6, or the whole thing over 6. So for me, either answer would be fine, but if you're doing homework problems, just be able to recognize that these two are exactly the same. Okay, and our last technique is to solve using the quadratic formula. Now the quadratic formula comes from completing the square. It's actually a really interesting process. I will make a separate video of that. I'll post it after this one. And if you're curious, you could actually see where the quadratic formula comes from. It's not just a bunch of random letters. It comes from completing the square. And what the quadratic formula says is if you have something in standard form, then the answer for x is always equal to the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. And just note that the whole thing is being divided by 2a. It's not just this. That's a common mistake. The whole numerator is being divided by 2a. So let's take a look at a couple examples. One example looks like this: x squared minus 3x minus 2. Sometimes people like to label what a is. A would be 1, b would be -3, and c is -2. So using our quadratic formula, x would equal the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. Cleaning this up, we get 3 plus or minus -3 squared is 9. 9 plus 8 is 17. And you always want to make sure everything's simplified. Square root of 17 doesn't reduce, so that would be the answer for this. And we have one more problem. What if we had negative 6x squared is equal to 3x plus 2? Now you can't just start labeling a, b, and c because it's not in standard form. So let's get all of these numbers on the same side. So it's equal to 0. I'll subtract 3x, and I'll subtract the 2. So we do have, it's in standard form. Okay, so a would be negative 6, b would be negative 3, and c would be negative 2. So using our quadratic formula, we're going to take the opposite of b, plus or minus the square root of b squared minus 4ac, all divided by 2a. There's a lot of negatives, so just be careful. We get 3 plus or minus the square root, and it's going to be negative 3 squared minus 4 times negative 6 times negative 2. And that comes out to be negative 39 over negative 12. Let me just make sure I did that right. 9, 4 and 6 is 24, so negative 48, so 9 minus 48 is negative 39. And 39, I mean, it's negative, so we know we're going to have to take out that negative 1, which turns into an I. But the square root of 39 is just 3 times 13, and that's not going to reduce. So as far as our final answer, we could write 3 plus or minus I root 39 over negative 12. Now another way to write this, sometimes people don't like having a negative in the denominator, so we could just multiply the top and bottom by negative 1 to take care of that. You don't have to, but you should be able to recognize different forms. And we get negative 3, and if you have a plus or minus number times a negative 1, it's still plus or minus, right? Like positive or negative 2 times negative 1 is still positive or negative. So these are the same. That's how we solve quadratic equations.